What we're going to look at in this video is the topic of composite functions. Now, think back to when we initially started describing functions and discussing them. We know that a function is a rule. It's a rule that links two things together. So, for example, if I gave you the function f of x equals x plus 1, we would know that we're able to link the function f of x to the value of x using this rule. So whenever we had a value of x, we could substitute it in here and get a different value out for f of x. So a function is defined as that. Now, a composite function is what we can do when we take two or more functions and we can compose them together to make a new function. So we can take two rules, combine them in some way, and make a new rule out of this. And the way to think about this is taking one function and using the output of that one function to create another. So if I tell you I have two functions, let's imagine I have got a function f of x, which I'm going to tell you is 2x, and I want to define a second function called g of x, which I'm going to tell you is that x is equal to x minus 3. Now, whatever value we put into f of x, we're going to get an output of 2x. Whatever value we put into g of x, we're going to get an output of x minus 3. What I'm able to do is use these outputs and compose them together to make a new function. So for example, I can make a new function called k of x. And I'm going to tell you that this k of x is the equivalent of f of g of x. What this means is I'm going to take the output of g of x and substitute it into f of x to create this new function k of x. Now, up here based on the rules, g of x equal to x minus 3, so this is the output I'm going to get. So that's the equivalent of me saying it's the f of x minus 3. Now, when we get something like this, we know that f of x is described by the rule 2 times x. Well, when I'm using f of x minus 3, I'm telling you the input, so the x that I'm going to be using, is x minus 3. So wherever there's an x appearing in the rule for f of x, I substitute x minus 3. So what that means is, I'm going to do 2 times the x minus 3 in a bracket because that's gone in place of the x here. And I can multiply at that bracket and get 2x minus 6. And this is now my new rule k of x. So we've composed the two functions together to make this new rule. I could have also said I could compose and make a new function h of x, which is given by the other way around by me saying it's g of f of x. And what this means is that I take the output from f of x and substitute it into g of x. Now I know the output from f of x is always going to be of the form 2x. So that means I'm essentially taking g of 2x. So wherever there's an x in the form for g of x, I'm going to substitute 2x. So I can take this new function h of x and define it as 2x minus 3 because I've substituted in 2x for every part of x in the definition of g of x that I have. This is how we composite function. An easy way of thinking about it is it's a function of a function. Let me show you another example. So imagine in this example, I'm going to tell you that f of x equals x cubed plus 1 and g of x equals 1 over x. So these are the two rules that f and g of x have, and this is the way they output. So imagine I tell you that in this case, my new function k of x is going to be equal to f of g of x. It's still the same logic as before, so it's the output of g of x being substituted into f of x. Now my output from g of x is 1 over x, so in this case it's going to be f of 1 over x. So wherever there's an x in the f of x function, I substitute 1 over x. So in this case, k of x is going to equal 1 over x cubed, because that's now in place of the x cubed, plus 1. So I can get rid of the bracket with the cubed and have 1 over x cubed plus 1. That is now my new rule, my new function k of x. And again, similarly like I had last time, I could also define a function h of x, which I'm going to tell you is g of f of x. So in this case, I'm putting in the output from f of x into the g of x. Now I know the output of f of x is this up here, the x cubed plus 1. So that's me saying I'm going to do g of x cubed plus 1. So wherever there's an x in the g of x function, I'm going to substitute that in. So I now know then that my h of x, my new function, is going to be equal to me substituting x cubed plus 1 there. So I get 1 over x cubed plus 1. And that there is my new function g of x. So I've got two new functions based on that. Composite functions, this is what we're going to do. And this is how we do it. I'll give you one further example. Imagine I tell you that f of x equals 4x plus 1. And I tell you that g of x equals a half times x. What I want to know is what the value of h of x is at x equal to 8. So i.e. I want to know what h of 8 is. But I'm going to tell you here that h of x equals f of g of x. So h of x is given by me composing the two functions together, f of g of x. Now, there is a couple of ways that this can be done. The first is, I can compose the functions and then substitute the value in, or I can substitute it in, then compose the functions. Now, the idea is that I should get the same value for each way. So let's have a look at that. So if I compose the two functions to begin with, f of g of x is the same as me saying f of a half x, because that's the form for g. So if I substitute this in, that's 4 times a half x plus 1. So at this point, I know h of x equals 2x plus 1. So now, if I wanted to get h of 8, I would substitute in the value of 8 at this point. So I'd do 2 times 8 plus 1. So 2 8s are 16 plus 1 gives me a value of 17. Now, another way I could have approached calculating what h of 8 is I could have done f of g of 8. So substituted the value of 8 in initially, got an output from that in terms of a numerical value, and then substituted it in. Now, g of 8, I could calculate using the function at the top. Well, that's just a half times x, in this case a half times 8, which is 4. So I now know g of 8 is 4, so that's the equivalent of me saying I want to calculate the value of f of 4. And if I substitute that in, I get 4 times 4 plus 1, so I then know that h of 8 this way also equals 17. When it comes to putting in numerical values, it doesn't matter which of the two ways round we do it, we stick to whichever one makes more sense to us, because regardless, we get the same answer out. So when we're working with composite functions, bear that in mind. Think of it in terms of a function of a function, i.e. we take the output from one function, put it into another, and we get ourselves a brand spanking new function.